Alright, in this lesson we're going to be looking at solving quadratics. We're going to focus on their graphs and vertex form, which is the first form that we've learned. Our objectives are to understand how to find a solution to a quadratic equation or graph. Remember, the graphs will look like parabolas. Our vocabulary is root, zero, intercept. These three words all mean the same thing. This is where a graph crosses the x-axis. In these situations, the y value, or the f of x value, mainly y, we call a zero. Second vocabulary is solution, the number that satisfies the situation. So here we have a graph. This is a parabola that is facing down. It opens down. Vertex at the top. We've got a line of symmetry through the middle. What we want to do is find f of x equals 7. Now remember that f of x is the same as y. So this situation is saying find the y of 7. What x will we get? Well, remember that when we solve these, because of the line of symmetry that goes down the middle, there's going to be two x's. So here we go to the y of 7, 5, 6, 7 here, and we go across, and we have two situations develop. One here, and one here. And then we're just going to estimate, to the best of our ability, what those answers would be. So it looks like if we follow these down, we're going to get an x of 1 and an x of 5. That's how I got those. So now let's go on to the more mathematical way of solving. So here we have an equation and we want to find a root. So remember, all roots mean that y equals 0. So we're going to rewrite this problem with 0 in for the y. So we have 0 equals 3 times x plus 1 squared minus 27. Well, in this situation, we now want to solve for x. Now, this one should come out perfect, so we won't have to worry about estimating or using exact answers, because it should work out. So we're going to add 27. So we get 27 equals 3 x plus 1 squared. Then we still have stuff on the outside of the parentheses. Notice the 27 and the 3 were on the outside. So now we have to get rid of the 3. So we're going to divide by 3. That's going to leave us with 9 equals x plus 1 squared. Now we want to get rid of this squaring. To do that, remember, we have to square root. By square rooting, we split the problem into two answers, because this is where that line of symmetry, two sides to the line of symmetry, comes in. We're going to have the square root of 9 as a positive 3 equals x plus 1. And we're going to have the square root of 9 as a negative 3 equals x plus 1. Because remember, the square root of 9 is both 3 and positive 3. Or positive 3 and negative 3. So now we're going to minus 1 on both sides. We're going to get 2 is x. So there's one of our answers. We're going to minus 1 on this side and get negative 4 is x. So there are two possible answers, 2 and negative 4. Alright, they don't always come out perfect, so here's what happens when we want an exact that doesn't come out perfect. So now we have a situation in function notation. We want to find exact zeros. Remember, that means that y is 0, or f of x is 0. So we're going to take out the f of x and we're going to put 0 in. So I'm going to rewrite the problem as 0 equals negative x minus 5 squared plus 14. Now one thing that could trick you in this situation is that there's a negative sign with no number. So remember, we can always put in a 1 in those situations, so it's really a negative 1. Again, we want to get rid of what's on the outside. Here it's a 14 and that negative 1. So first, let's get rid of the 14. So we're going to minus 14. So negative 14 equals negative 1x minus 5 squared. Now I need to get rid of the negative 1 by dividing by negative 1. So I'm going to be left with 14 equals x minus 5 squared. Our next situation is to get rid of the square. So we want to square root. By square rooting, we're going to get a negative and positive answer. Now 14 doesn't come out perfect. In this situation, we want exact zeros. And because of that, we're going to leave it square root of 14. That would be exact. If we square root this, we'd get a decimal that has to be rounded. We don't want a rounded answer. We want exact. So we're going to go with square root of 14 equals x minus 5. We're going to go with negative square root of 14 equals x minus 5. Now at this point, we just have to add our 5's on both sides of both equations. And remember, square roots and non-square roots can't be added, so we get an answer of square root 14 plus 5 equals x as one of our solutions, and negative square root of 14 plus 5 equals x as our other solution. Alright, next situation. We want to find estimated x-intercepts here. Again, x-intercepts are when y equals 0. So notice how I've set up situations where we wanted roots, zeros, and now x-intercepts all ask for the same thing, a y of 0. This one's going to be estimated, so when we square root this, we're actually going to use a rounded decimal. So, let's rewrite the problem. 0 equals 2 times x minus 6 squared minus 16. Again, we have outsides, 2 and negative 16. So I want to get rid of those. So we got to get rid of the minus 16 by adding 16. It's going to leave me with 16 equals 2 times x minus 6 squared. I now need to get rid of the 2 by dividing. So I'm going to get 8 equals x minus 6 squared. Okay, at this point, I want to square root. This is going to split it into two answers. Now in this situation, I actually want to do square root 8 and round the answer. So I get my calculator out, type in square root 8, hit equals, and I get the answer 2.828427. That's just too long. So we're going to round it to one decimal spot. We're going to call it 2.8. So I'm going to go 2.8 equals x minus 6, and negative 2.8 equals x minus 6. And these are estimated versions of the situation. So now we just have to add our 6 on both sides. So 2.8 plus 6 is going to give us 8.8 equals x. And here we're going to add 6. Now this is a decimal and an integer, so we're going to be careful with this. So we've got negative 2.8 plus 6. And we get 3.2 as our other x value. So 3.2 equals x. So now we have our two solutions there. Notice now we have used some rounding to go along with our exact answers. Our last situation, this one I'm going to tell you, not a root or anything, we're just finding a regular solution for negative 5. But I have set it up so this will be an imaginary number, so we can remember how to deal with those situations. So we want to take our negative 5, put it in for f of x, so we're going to put negative 5 there. And we're going to rewrite our problem to give us negative 5 equals 0.5 times x plus 7 squared plus 8. Okay, at this point, we want to get rid of our plus 8 and our 0.5 there, so we're going to minus 8. It's going to give us negative 13 equals 0.5 times x plus 7 squared. Okay, this we're going to divide by 0.5. Now remember, when we divide by 0.5, that's the same as multiplying by 2. So this is going to give us negative 26 equals x plus 7 squared. We now want to square root. We're square rooting a negative, so this is going to give us imaginary numbers. 26 doesn't come out perfect, so we're again going to go to our estimate. So when we square root 26, we get 5.099. If we go just one decimal, we're going to call it 5.1. But because of it being a negative, it's going to be 5.1i equals x plus 7, and negative 5.1i equals x plus 7. We're now going to subtract 7 on both sides. Now, because this is an imaginary number, we can't do this subtraction, so we're actually going to end up with 5.1i minus 7 equals x. So there's one solution. And we get negative 5.1i minus 7 equals x. There's our other solution. So now we have looked at how to solve these quadratics in various situations. So hopefully you can go ahead and do this in any of these situations, and maybe even understand how to do it in others. So if there's any part of this that you need to rewatch, make sure you pause, rewind, and rewatch it, and bring questions to class. Thank you.